The original method of A inverse, finding determinant. Step 1, if det 0, determinant 0, then inverse does not exist. If determinant not equal 0, then we can proceed for finding inverse by the second step, adjoint, which is nothing but cofactors matrix of A transpose, or you can go by options method. What is the options method means? One of the option is answer. We don't know that option. Denote each option by A inverse. Whichever satisfies A into A inverse is equal to identity matrix, that option is the required answer for A inverse. Okay, that is simple. Now the next one, either you consider as note point or some short method or some results for regarding determinants. Okay. VVI means very, very important. The first one is, when you have in a determinant two types of elements only, all diagonal elements are same, and all non-diagonal elements are also same, but it is of different element. Let us say x, y, 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 x, y, 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 x. See, here all diagonal elements are considered as some x. All non-diagonal elements are also same, but it is a different element y. So only two elements. One is diagonal elements, other is non-diagonal elements. Answer for this, without using the previous procedures, just x plus 2y into x minus y whole square. In every row, you have 1x and 2 y's. Just add. You will get x plus y, which is the first step, x plus 2y. In the second and third step, subtraction. That means in every row, that means if I take first row, first element minus second element, first element minus third element. Don't take same elements subtraction, which gives 0. Okay. So, and extension to 4 by 4, 5 by 5 also. Determinant x, y, 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 x, y, 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 x, y, 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 x is equal to x plus 3y into x minus y whole cube, and so on. Okay. So in this case, I will do the previous gate question example, which is asked in 2013 2 marks. The question is, the value of determinant 2 1 1 1 1 2 1 1 1 1 2 1 1 1 1 2 is solution. So here x is equal to 2, comma, y is equal to 1 implies answer is 2 plus 3 into 1 into 2 minus 1 whole cube, which is nothing but 5. If you expand by original procedure of determinant, that is every element multiplied by its cofactor and then adding in a row or column, that will take in this example 3 to 5 minutes also. Next, second note point. If two parallel lines are identical or proportional, then the determinant value is 0. What is two parallel lines means? Either two rows or two columns. When they are same, identical means same. Proportional means constant multiple proportion. That means first row say 1, 2, 3. Second row 2, 4, 6. That second row is obtained as multiple, I mean 2 times of the first row elements. That is called 2 is a proportional constant. Okay. So in this case that is C. C2 is equal to 3C1. Okay. Or R1 is equal to 4R3, etc. This 3 is a constant multiple of another row, 4 is a constant multiple of another column, etc. Okay. In this case, see, let A is equal to 1, 5, 7, 2, 0, 4, 3, 15, 21. So in this, let A is equal to 0 since third row is equal to 3 times of first row element. Each element of third row is obtained by 3 times of the corresponding elements of the first row. So 3 into 1, 3 into 5, 3 into 7. In that case, time, you are saving the time or not? If you are remember these properties, these results well, okay, these properties or results thoroughly if you remember, then you can save the time. Okay. Number 3. If two parallel lines are interchanged, then the determined value changes by sign only. For example, in this case, how much determined? 5. If you interchange first row, second row, or third column, fourth column, you will get the answer 5, but change of sign. Sign only means plus becomes minus, minus becomes plus originally, that is. Say example. Let delta represents a determinant 1, 3, minus 2, 4. What is this value? It looks like 2 by 2 determinant, which is a previous definition first result 1 into 4 plus minus of AD minus BC 1 into 4 minus of minus 2 into 3 4 plus 6 10. Okay, apply R1 interchanges. I have only 2 rows and 2 columns. Just apply interchanging. We get a new determinant minus 2 4 1 3. In this determinant, I have applied first row, second column changes. Okay, interchanging. So second row elements will go to first row position, and first row elements will come down to second row elements. So what is the answer for this 2 by 2 determinant? AD minus 2 into 3 minus BC 4 into 1. So minus 6 minus 4 simplifies to minus 10. So 10 is same, but plus becomes minus, minus becomes plus. When you interchange 2 rows, 2 columns, the determinant value changes by signature. I mean changes by symbol only, sign only. That is. In this last property, a determinant value is unaltered. Unaltered means has no change. by applying R2 plus 3R1, R1 minus 2R3, C4 plus C1, C2 minus 4C3, etc. That is sum of two rows, two column operations. What is R2 plus 3R1 means? Every element of R1 multiplied by 3 and adding correspondingly the elements of R2. The result will be put in R2. So when you consider, when you take or when you apply this operation, where it is affected? The first two. Here R2 will be affected. In R1 minus R2, R1 minus 2R3, if you are going to take or applying, in the next step R1 will changes. That is R1 will affect. In this case C4 will affect. In this case C2 will affect. Okay. So just give an indication by some color. Where I put blue color, that will be changes in the next step when you are applying or taking that operations. So here is a place for this result. I am taking a small example. Previously I told let delta. What is delta? 2 by determinant I took 1, 3, minus 2, 4. How much answer? 4 plus 6, 10. So apply R2 minus 3R1. Okay. We get a new determinant. In that new determinant, only R2 changes. R1 remains same, 1, 3. So take care. R2 position is minus 2, 4. Minus 3 into R1. So minus 2, minus 3 into 1. That means minus 5. Next, this is R2 element 4. 4 minus 3 into 3. So 4 minus 9, that means minus 5. This is the new determinant. What is that? Determinant 1, 3, minus 5, minus 5. Which simplifies to minus 5 plus 15 is equal to 10. No change. Unaltered means no change. You can consider these are results or properties. Result 5. Determinant A transpose is equal to determinant A. Determinant A inverse is equal to 1 by determinant A. Determinant A into B is equal to determinant A into determinant B. And determinant A plus B is not equal to determinant A plus B. So far in all the previous properties, I have considered one simple example for satisfying or proving that corresponding property. Now onwards, at home, when you have the time, take a 2 by 2 matrix, find transpose, find inverse. I shown you that previous examples and check that whether they are satisfying the above properties or not. Number 6. AB whole transpose is equal to B transpose into A transpose. AB whole power theta is equal to B power theta into A power theta. Adjoint AB is equal to adjoint B into adjoint A. And finally, AB whole inverse is equal to B inverse inverse. In all these four definitions, transpose, conjugate transpose, adjoint, inverse. So, inverse of product, transpose of product, transpose conjugate of product, whatever it may be. So, the answer is product of their inverses, product of their transposes, product of their adjoints in reverse order. Okay. Next. A into adjoint A is same as determinant A into identity matrix. Similarly, adjoint A into A. When you multiply two matrices, if you have the identity matrix in whatever the order, A, B, B, A, implies and implied, one is called the inverse of the other. B is equal to A inverse. Similarly, A is equal to B inverse. Okay. Next. They can ask directly statements like this or simple examples, prove that or mean which are the options satisfied, etc. Determinant K into A is equal to K power N into determinant A, where K is a scalar. Next, determinant of adjoint A is equal to determinant power N minus 1. Det A to the power N minus 1. Similarly, determinant of adjoint A is equal to det A to the power N minus 1 whole square, and so on. N is the order of matrix A. K is scalar. So if I take K is equal to some 3 into A, what is the meaning of 3 into A, which is a scalar multiple of a matrix? Every element of matrix A multiplied by 3, if I take 3A. Similarly, K into A means every element of matrix A multiplied by K. So, at a glance, please go through seriously important properties. This is very, very important. This question asked in 2015. For A is equal to 1 tan x minus tan x 1, comma, the determinant of A transpose into A inverse is option A secant square x, option B cos 4x. See, some people pronounce it or read as sec x, some other people pronounce it as secant x, which is a trigonometry C1 D0. Solution. So you can find transpose, you know that A inverse and matrix multiplication, and finally they are asking determinant. Okay, everything, it is a 2 by 2 matrix. So that is first method. Or use the above properties or results. The question is finally determinant A transpose into A inverse, which is looks like this is one matrix, this is another matrix. Refer first this one, fifth property. So I can write det A transpose into det A inverse. Det A transpose det A inverse. Refer fifth one. Determinant A into 1 by determinant A is equal to 1, since using result 5. Let m power 4 is equal to I. M comma m square comma m cube not equal to I. Then for any natural number k, comma m inverse equals m power 4k plus 1. Option B, m power 4k plus 2. Option C, m power 4k plus 3. Option D, m power 4k. Solution. So given m power 4 is equal to I, let us say equation 1, implies m cube is equal to m inverse. Let us say equation 2. Just for equation 1, both sides multiply by m inverse. M inverse into m power 4 is m cube. M inverse into I is m inverse. Any matrix into identity matrix will give any matrix only, but not identity matrix. A into I is A. Now, some problems whose solutions are obtained by options method. What is option A? So we have to find first of all m inverse, which is equal to one of the options A. We got m inverse is equal to m cube. So what is option A? M power 4k plus 1. This is according to indices. I can write m power 4 whole power k into m. You know that our 8th, 9th class, childhood class properties indices. A power m plus n can be written as a power m into a power n. A power mn can be written as a power m whole power n using that power. So m power 4 is identity matrix using equation 1, power k into m. I into I square, anything is I, which is equal to m. Okay, so but m not equal to m inverse. Okay, here what I have done, multiply both sides by m inverse. You will get equation 2. So option B, m power 4k plus 2, m power 4 whole power k into m square, I can write. Okay, since a power m plus n is equal to a power m into a power n, a power mn can be written as a power m whole power n from our childhood class properties. M power 4 is I into m square, which is equal to m square. This m square not equal to m inverse. Option C, m power 4k plus 3 can be written as m power 4 whole power k into m cube. M power 4 is I, m cube is m inverse. Okay, since from 1 and 2, so m inverse into identity matrix is m inverse. Okay, so therefore C is answer. Similarly, 4 by 4, 5 by 5 higher order determinants. How to evaluate? In the easiest way, by applying elementary operations. That is either row operations or column operations. Procedure for higher order determinants. That is 4 cross 4, 5 cross 5, etc. There are 2 steps to evaluate higher order determinants. Step 1. Select a row, oblique column, either row or column. This is slash or oblique or any symbol. And then select an element. Step 2. Make all other elements zero. By applying R2 minus 3R1, R1 plus 4R2, C4 minus 2C1, C2 plus 4C3, etc. These type of row or column operations, addition, subtraction, this is addition, etc. These are also called elementary operations, elementary transformations. Okay. So, in a determinant, if you apply these type of operations, the determinant value is unchanged. That I proved already in previous results. That is 4th result. Then expand them. So make all other elements 0. Then expand determinant using the definition. Suppose if you select first row, except one element, you have made all other elements zeros. So then easy to evaluate the determinant, because what is the determinant definition? Every element multiplied by cofactor. If sum of the elements 0, 0 into anything is 0, which is saving the time or not, by comparing with original method. Example, this question asked in 2014 GATE, 2 marks. The value of the determinant zero, 1, 2, 3, 1, 0, 3, 0, 2, 3, 0, 1, 3, 0, 1, 2 is So what is the procedure? Take any row or any column, then select one element. So using that element, make the remaining elements 0 in that selected row or column only. Whenever you select a row, make all other elements 0. Then expand the determinant. That is the procedure. Okay. Now solution. So I already told you half an hour back. So selecting a row or column means which is already existing zeros. For example, second row, 2 zeros. Similarly, second column, 2 zeros. More zeros compared to other rows and columns. So you can select either second row or second column. And then select a non-zero element only, not zero element. Here also element means here please write non-zero. Any non-zero element, better small number. Okay. So if I select this is second row. Okay. And then selecting an element 1. This is. So select second row. Then select element, small element, that is 1. Don't take zero element to be selected. Non-zero element. In all non-zero elements, select the smallest element, which is time saving, and you will not get silly mistakes also. So, if I select row, apply column operation. This is the logic you have to follow. All of you please remember. If selecting row, apply column operations. If selecting column, apply row operations. Opposite in nature. Opposite nature. Similarly, lower triangular matrix already defined 2 hours back. Elements above the diagonal 0. Upper triangular matrix, elements below the diagonal 0. That is called opposite nature. Similarly, here also, when you are applying operations, before that, you select a row or column. If row to be selected, apply column operations. Similarly, if column to be selected, then apply row operations. Okay. So, here I already select the element 1. We should make all other elements zeros. Already in the second row, 2 elements 0. The third element is not equal to 0. The third element means number 3. This number 3 is in column 3. This number 1 selected element in column 1. So everyone please tell a third column with first column operation. That is apply C3 minus 3C1. In textbooks or in materials, this is also be written as C3 changes to C3 minus 3C1. Not required to write, because it is your answer is finally they are looking that whether you are putting correct option or writing that filling the blanks correct or not, but not the procedure. So instead of writing this lengthy way, better write C3 minus 3C1, which will affected by C3 only. When you are writing these operations, the first thing will be affected in the next step. Okay. We get a new determinant, again 4 by 4. In this new determinant, only C3 column changes. Remaining C1, C2, C4 doesn't change. We'll give as it easily 0, 1, 2, 3. This is C1 elements, C2 elements 1, 0, 3, 0. This is unchanged, same. Next C3 changes using this operation. So hold like this, C3 with C1. 2 minus 3 into 0, that is 2. 3 minus 3 into 1, 3 minus 3, 0. 0 minus 3 into 2, 0 minus 6, simplifies to minus 6. 1 minus 3 into 3, that is 1 minus 8, simplifies, 1 minus 9, simplifies minus 8. So only C3 changes because I took this C3 operation. C4, no change because I did not write anything about C4. So remains same, 3, 0, 1, 2. This is the new determinant. Now I had made all other elements zeros in the selected row. So expand the determinant. Use the definition of determinant. What is the definition of determinant? Every element multiplied by its cofactor and then sum. Sum means adding. So what is, while expanding determinant, while finding cofactors, that means adjoint of a matrix, please remember put the symbols by some other color above the elements of the row or column. When you select a row or column, before expanding determinant or finding adjoint A, you put the symbols above that elements which are helpful to us. Okay. For 3 by 3, 2 by 2 doesn't put the symbols because everyone can do very fast. But higher order determinants, you please follow my symbols by some other color. Okay. So this one is second row, first column, A to 1. So I value 2, J value 1. So minus 1 whole power 2 plus 1, which simplifies to minus symbol. So this is minus. So every element in a row, first element in a row or column will take 3 seconds, 2 seconds for finding that symbol. Remaining elements in that row obtained by alternatively plus minus symbols. Minus, plus, minus, plus. Okay. Now is equal to. You will be getting the determinant. What is the determinant definition? Every element multiplied by cofactor. 1 into, what is the cofactor of this one? that is symbol is blue color -1, that is called -1 whole power I plus j into minor of this element 1. What is the procedure of minor of an element? So where the element, that means that element is located in a row or column, immediately you delete. You will get a smaller matrix. That smaller matrix is a submatrix. That submatrix determinant is called minor of element. Please refer back, that is. So deleting second row, first column, you will be having 3 by 3 determinant, which are that 1, 2, 3, 3 minus 6, 1, 0 minus 8, 2. Since by definition of determinant. Okay. Once you reach 3 by 3 determinant, you can follow by previous procedure, or you know, everyone know 3 by 3 determinant. Once again, I want to expand this 3 by 3 determinant by last row, because one element is 0 compared to other rows. Symbols plus, minus, plus. So is equal to -1 into bracket start 0 into time waste. 0 into anything is 0. Earlier in the first example of 1994 A inverse, 0 into minor also I wrote, because that is useful for some other problems. But once every time if you get 0, doesn't require to write that smaller matrix determinant, because time waste. So next, blue color minus into black color -8. Minus into -8 plus 8 into deleting third row, second column. What is the minor of this -8? A 2 by 2 determinant 1, 3, 3, 1. Okay. Last element plus 2. This 2 is in third row, third column, delete. These 4 elements is the minor. That is 2 into determinant 1, 2, 3, -6. Close the bracket. This simplifies to -1 into 0 plus AD minus BC. 8 into -8 plus 2 into AD minus BC. -6 -12. So this simplifies to 88. So the blue color line indication is I have expanded the determinant by that row. Definition. This is another types of matrices, 9 definitions, which I grouped into 2 definitions. One definition containing 3 types, other definition containing 6 types. A square matrix A is said to be number 1, idempotent matrix if A square is equal to A. This A square is nothing but matrix multiplied by itself. A square means, A square doesn't mean that square of every element. A matrix A multiplied by itself, which is nothing but square of that matrix. So I will provide an example immediately. Everyone, please verify. A square getting A or not. A is equal to 1, 0, 0, 0 implies all of you. A square is equal to 1, 0, 0, 0 multiplied by again 1, 0, 0, 0. Okay, so what is that answer? First row into first column 1. First row into second column 0. Second row into first column all are 0, 0. Once again you will be getting A. Number 2. Involuntary matrix if A square is equal to identity matrix. example, A is equal to minus 1, 0, 0, 1. From this, again A square, minus 1, 0, 0, 1, minus 1, 0, 0, 1. Please multiply. And the third one, nilpotent matrix. If a power n is equal to 0, what is a power n? N is an integer, positive integer. 1, 2, 3, 4. Wherever you have a power, some positive integer is equal to 0, such matrix is called null matrix. Where n is positive integer. The smallest value of n is called, this is second level basics, index of A. Example, A is equal to 0, 1, 0, 0. So first, here A is a non-zero matrix. That means n value 1. So if A is a non-zero matrix, you have to start with A square, simplification. If A square 0, then A is a nilpotent matrix. If A square not equal 0, then you consider A cube and find it. If it is not equal 0, then find A power 4. Wherever you have that A power some positive integer is 0, such matrix is called null matrix. What is the smallest value of n means? For example, in the given problem, if A square is itself 0, then automatically A cube 0, A power 4 is equal to 0. The smallest of all the positive powers integers is called index only, that is. So I am doing A square, that means 0, 1, 0, 0 multiplied by 0, 1, 0, 0. First row into first column, 0 into 0 plus 1 into 0 simplifies to 0. First row into second column, 0 into 1 plus 1 into 0 simplifies to 0. Second row into first column, 0 into 0 plus 0 into 0 simplifies to 0. Second row into second column, 0 into 1 plus 0 into 0 simplifies. You will be getting 0 matrix. Therefore, A is. So in the beginning only we got 0. So index, comma n is equal to 2. Why I decided here index n is equal to, if you do next step A cube will give 0, A power 4 0, time based. So if you do like that, the smallest positive power in that case, n is equal to 2 only. So please check here also, minus first row into first column, minus 1 into minus 1 plus 0 into 0 simplifies to 1. 0, 0, 1 is equal to I2, 2 by 2 matrix. So another definition which is containing 6 types matrices. A square matrix A is said to be, number 1, symmetric matrix if A transpose is equal to A. Side by side matrices. In this, number 1. Hermitian matrix if A power theta is equal to A. You know that A power theta means A conjugate and then transpose. One condition to remember to easily say that one of the option is Hermitian matrix if they ask. Diagonal elements must be real numbers. Example. A is equal to 1, 2 plus I. This is 2 minus I, 0. So all of you please find A conjugate. Okay. Conjugate of every element, you know that. 1, 2 plus I conjugate is 2 minus I. 2 minus I conjugate is 2 plus I, 0. Then A power theta definition is A conjugate and then transpose. So transpose of this matrix 1, 2 plus I, 2 minus I, 0, which is nothing but our A. Verified or not? Similarly, verify later examples. I shown one example there. A is equal to A, H, G here, B, F, F, C. Please find A transpose, all of you. Check it. Second definition. So one side real numbers matrices, other side is at least one element is complex matrix. So the left side matrices definitions are real matrices. The right hand side definition matrices are complex matrices. Skew symmetric matrix. That is if A transpose is equal to minus C. In this, important condition is by saying immediately one of the option is answer. Diagonal elements, these are the key points, are either 0 or all 0. Example, A is equal to 0, 1, minus 1, 0. 0, minus 2, 3, 2, 0, minus 1, minus 3, 1, 0. So please verify these two examples. On the other hand, skew Hermitian matrix if A power theta is equal to minus C. In this condition is diagonal elements are 0 or purely imaginary. So what is purely imaginary means I, 2I, etc. That is I minus I by 2, 3I, etc. A is equal to 0, 1 plus I. This is minus 1 minus I. So please take either 0 or purely imaginary. Here all diagonal elements are real numbers. All diagonal elements are zeros. Please check. Here all diagonal elements are 0. So for this, I am finding A transpose. 0, minus 1, 1, 0. Which is nothing but minus of, I can write 0, 1, minus 1, 0. Which is nothing but minus A. So in this, A bar, 0, 1 minus I, minus 1 plus I, minus I, every element conjugate. So, and then A power theta, that is transpose of this matrix, 0, minus 1 plus I, 1 minus I, minus I. Take minus common, minus can into that matrix is 1 minus I, minus 1 plus I, which is nothing but minus A. We got that. So determinant of even order skew symmetric matrix is non-zero and is a perfect square. Determinant of odd order skew symmetric matrix is 0. That's why I am considered 2 examples of skew symmetric. So in a skew symmetric, if it is odd order means 3 by 3, 5 by 5. In that case, determinant is 0 without evaluating, or you can verify for this det 0. Even order means 2 cross 2, 4 cross 4, etc. If it is a skew symmetric matrix, the determinant value is a perfect square. So you can find here det A 0. In this case, det A value 1. 1 can be written as 1 square. This is purely imaginary or 0. Okay. So remaining definitions we'll discuss tomorrow.